Morning, everyone. We'll give folks a few more minutes to join. Just some quick housekeeping rules. The chat is open, so if you have questions, you can drop those in and they will be addressed at the end of the presentation. We're just giving a few minutes for participants to join. And once again, just a housekeeping reminder, the chat is open for everyone. So if you have questions or thoughts as we go along, please put those in and the panelists will address them at the end of the presentation. And welcome to everyone. We're still having folks trickle in.
Great. Should we get started, Christina? So we have plenty of time for questions at the end.
I think we should. It's those joining has slowed down, so please take it away.
The tardy bell has rung. All right. Welcome, everybody. Thank you for joining us for the Textile Conundrum webinar. My name is Lori Johnson. I am the founder of Circular Colorado, a local nonprofit here in the state, working on creating end markets in order to create circular economies for materials in Colorado and in the region. We are lucky enough to be the administrators of the Circular Economy Development Center. This is a framework that was brought around by a bill passed here in Colorado that created this center. We have the contract with the state to run this center, create the strategy, which we've done, and we are now in our third year of the Circular Economy Development Center. This center is funded by Colorado Circular Communities, or C3, as we lovingly call it. It is an enterprise fund here in Colorado made up from tip fees at the landfill assessed per ton. Goes into this enterprise fund and provides grant funding for recycling and circularity infrastructure, equipment, and everything that we need to make circular economies. So we started out, I'm going to give you a little history here with the Circular Economy Development Center. We partnered with RRS, a firm that did an end market gap analysis for us to try to see what were the major materials that we should focus on. We had a pretty good idea what those would be. But one of those, not to our surprise, was textiles, right? We're seeing a lot of textiles go to the landfill. So today, what we want to do is talk to you about a little bit of the conundrum, as we call it, of what's going on and why we don't have circularity today for the textile industry, full circularity. And then we want to tell you what we're doing to work on that. So while this is about textiles, I'm going to kind of do an overview of things for you of the textile industry and the process and the supply chain. I do not claim to be a really deep dive subject matter expert, but I know enough to be dangerous and to tell you where we're headed with it, with all the experts that we have. So with that, we're going to get started. And let's talk about our first step with the Circular Economy Development Center and what we do. So the first thing we do when we're trying to solve for any material, we did tires earlier this year, is we take a look at the supply chain. Many of you are probably familiar with this, but at a very high level, we look at what it takes to take end-of-life material, so in this case, it would be a textile, and how we have to collect it, We typically in recycling, as we all know, have to sort. Then we have to process, which could be anything from grinding to baling to shredding and some other technologies. Then we need to, in textiles, prepare that material. And that material then for textiles needs to get drawn, spun into a yarn. And then that yarn is weaved into a fabric. And then that fabric is dyed and finished. And then it is cut and sewn typically into a garment for what we're talking about. And what we're looking to do is at the end of this is to have textile to textile circularity. So then that garment at end of life obviously goes right back into the front of this process. So at the Circular Economy Development Center, or the CEDC, so I'm now going to use that acronym to shorten it. What we do when we take on a project like this is we first identify the gaps and we say, why don't we have circularity, right? Sometimes it's super obvious, sometimes it's not. Sometimes it's straightforward, sometimes it's complex. Textiles is somewhat straightforward and somewhat complex. So I'm going to go through this and show you what we've identified as the gaps, and then we'll talk through in this webinar of what we're doing to work on them. So when we first started out, we all thought, consultants and us were like, hey, we'll do a textile MRF. That's great. We'll get all the textiles together. We'll sort them all out. But at the end of the day, as you can all imagine, what you find is the reason there are not big MRFs throughout domestic or international is because there are not the markets for the materials. And a lot of that reason, as we'll talk about through this hour, is because they're not all homogeneous, right? It's not all polyester or all cotton. We have a lot of blends and a lot of different blended materials. So that's one big gap would be a MRF, because to get in the feedstock. However, that's not our first step. So the next step was processing, and we took a look at that. And there's all different types which we're going to review, from mechanical to chemical. And one of the biggest challenges there, obviously, are the fiber types, right? Like I just said, it's not all one type of fiber. There's multiple. Then we looked beyond that and said, okay, well, if we could process this, even if we could process just, say, 100% polyester, 100% cotton, are there people to do that? Yes, there are. Well, then how do we then prepare that material to then move into the manufacturing of textiles? So that was another big exclamation point or a gap. Then we got to spinning in the space of yarn. That is developed. People know how to take yarn. They know how to spin yarn from fiber. They know how to weave yarn into fabric. So that's really more about scaling and applying here domestically in the US in terms of what it costs. And then we got to dye and finish, which we're also going to talk about. That also is a known process. And as you know, common process and probably everything that you're wearing today. It does have some environmental impacts that we're going to talk about and why you don't see a lot of that happening here domestically. And then finally, we'll get to cut and sew, where we'll talk through why we don't see a lot of this happening. And primarily that has to do with the cost of labor. And when we get to the end, we're at textile to textile. And so we'll break down, like I said, kind of these exclamation points is what we're going to focus on here. So in the gap analysis done by RRS, and these slides will be shared afterwards, so you can absolutely go to the website address at the bottom, and you'll be able to see that or download the report. We first looked at the textile waste flow. As I'm sure many of you know, and why you're on this webinar is because you know that the majority of textile waste today, residential, commercial, and institutional or industrial, is going to landfill or being incinerated. These numbers may shift a little bit. Some of these studies were from 21, 22, and then also the assessment that RS did in 24. The important point is that it's the majority. A lot of it, as we know, goes to donation and thrift, our thrift partners, which we love, and thank goodness for them, or we would see probably even more than that percentage going to landfill. They go through everything and take out what they can for resale, which is reuse, which is perfect in the recycling supply, hierarchy. And then the rest of it goes into different categories. Some of it is exported for reuse and resale, 45% per this report. Some are used for industrial rags, but I think we all know if you're at home or working on a car or whatever you're doing, you use a rag, what usually happens in the life to that. And then there's shoddy and stuffing. So your dog bed might be full of this, or you may have something that has insulation that has been made with this as well. And again, there's landfill and incinerators discarded, and then fiber to fiber recycling right now is very less than 1%, so not so much a factor today. But here's kind of what the landscape looks like for that textile waste flow. So that was the first thing we looked at. And as we talked about earlier, if you go home, it's super interesting to do. Go home, look at the garments that you wear, and look at the labels, right? You probably might have some things that are 100% cotton or 100% polyester. Those are the easier ones to recover. But you also will have blends. So you may have a cotton polyester rayon blend, or you may have anything that you see here, things mixed with spandex. Some of the challenges that we find, I think, in this textile world is some of the what we feel is the most comfortable, the softest, and all of that typically is a blend, right? So you're going to see a lot of that material. Where you can keep this homogeneous, 100% polyester or 100% cotton, it makes the process easier. But that's not what we have and to deal with, and so we need to find solutions for all of these blends. So now we're going to kind of look at the processing for recycling and kind of the whole gamut. This diagram is a little complex, but we're just going to work our way through it. We're not going to dive into deep detail on every single process here. The CEDC and Circular Colorado always work for mechanical recycling first. That's what we're trying to do, right? We want the lowest environmental impact on the material, and we want to see if mechanically we can get it back into a form that it can be returned to a product. So mechanical, I think, is pretty straightforward. It's grinding, shredding, all of that type of thing. There's also things that may fall in the material recycling space like dissolution, but those also use solvents. And so when you get into things that use solvents, you get into other, issues like the storage of these and, chemicals or solvents and the discharge and things like that. So while it's still a what we would consider a good solution, there's some folks out there doing it with polypropylene and some other things. We would put that kind of below mechanical recycling as far as what we're striving for. And then you have this entire kind of half moon of, about 5 or 6 different processes that are, you have biochemical processes, chemical, sometimes you'll hear it called advanced recycling, chemical recycling. We actually do have a really great company here called Terraform that uses oxidation and to deconstruct the textiles. So we're keeping a really close eye on them. We have all different types of things from pyrolysis, gasification. However, we focus, I'll just keep reiterating this, on the mechanical processing, mechanical recycling, and that's the solution that we're going after primarily. As we see some of these other biochemical and chemical things progress, then we will continue to see if there's solutions that we can use there, as long as they're environmentally friendly, to deal with the textile problem. So preparing the input, when we look at that on our chain, like I said, mechanically recycling, it produces basically fibers for the shoddy or the stuffing. You can also get a recycled PET flake from like clear plastic bottles. So oftentimes you'll see, I used to be a plastic bottle. And it can also be put back into polyester textiles. So today there are many 100% polyester shirts that were made from rPET flake. So they used to be a plastic bottle, so to speak. And then you have thermomechanical recycling. So this is essentially, it uses heat, melts into a flake, and then makes flakes into pellets. And then these pellets can then be used also in textiles and other manufacturing through extrusion. And then you have chemical recycling, which we just talked about. And this is, if you think of a polymer, which is a chain of monomers, there's different processes to break that chain down into their simple monomers so that they can go back again into another process. So those get to be very complex. And like I said, today we're really working on the mechanical and some of the thermomechanical recycling to see what we can solve here for circularity. So here, we're going to kind of talk about what happens in this drawing and spinning. So drawing is a process where slivers, like loose ropes of fibers, are pulled through a series of rollers that are going at really high speeds, and it straightens and aligns those fibers to make them eventually into a light strand. Those strands are then taken and go into the spinning process. And I think many of us think back to like the spinning wheel, and we can remember like you would spin, fiber into yarn. And at a advanced, a manufacturing industrial level, this is what we're doing now today with large machines. And then that spun yarn can go and be woven into fabric, as you see here. And then that fabric can also be knitted. So weaving blends a fabric, and knitting actually creates a fabric by interlooping the yarn. And so that's a little bit more stretchy. And so what we did when we looked at this is we said, okay, well, maybe what we need to do is start with manufacturing in Colorado and work our way back, right? So folks know how to, spin, they know how to weave, they know how to knit, and then of course they know how to cut and sew. And we found some folks that were willing to set up, water jet weaving looms and knitting and spinning and all of that, and do what's called yarn forward, to make a yarn forward site where we would still have to import the yarn. And we're going to talk about why we would have to do that. It's mostly the dyeing. But then we could manufacture these textiles here in Colorado and then recover them again to go back into a system. Hoping that here eventually we would have the recycling systems in place to utilize this manufacturing. Again, what we found though, for today, is it really came down to the economics of why that wouldn't work to start further down the line and work our way back to recycling. So let's talk a little bit about the dyeing process.
Hey,
You can see
Lori,
those. Yes. Yes.
there's a little hide thing in your slides so that we can hide the sharing.
Oh, is that still there? Hold on one second. There we go. And I can't see you guys, so I'm sorry. All right. Well, now how's that? Better?
Looks good, thank you.
Okay, great. You got it. Okay, so let's talk about dyeing. A big industrial process. You can see essentially those vacuum sealed vats there in the back. So dyeing uses a lot of water and a lot of energy. Essentially, the process starts with washing the fabric, and then it's submerged in a dye bath. And that's where heat and time are used to transfer the dye to the material, and to the fibers. And then after the dye has been set, so it's colored, the color is fastened to the fabric. It is then rinsed, washed, and dried. So if you can imagine the amount of water used, it starts with water and it ends with water. That's a big concern. Then after that, let me go back here and talk about the different types of dyeing. There's another type of dyeing that we're going to talk about too, where pigments are added prior to this. So this is not the only way to do it, but it's the way that the majority of textiles are being done. So after the fabric is dyed, then it's coated. So you can see this big long thing looks kind of like an oven. And then you have your finished fabric. So that's where essentially your fabric becomes, it's color fast. It's not, some of it may come out in the wash a little bit, but you're not going to lose all of your dye throughout the life of the fabric. Let's talk about dyeing and why we don't have, as we found, as many textile mills here domestically. So much of this has to do with the environmental impact of dyeing. Dyeing and finishing generates, like we said, a lot of water, and those waters can have all types of heavy metals and chemicals that are of concern and are monitored by the EPA. Things like chromium and arsenic. We also found that there's a lot of PFAS that can come out in this process. And so dyeing is not as common in the US since the EPA and the Clean Water Act. It requires the advanced treatment of this wastewater, and the cost to do that is complex and can be prohibitive. So there are other dyeing technologies, which we also are taking a look at, so that if we get to that point, right, where we have the processing figured out, and we can get to the yarn and we can weave it, right, and we can get to where we can dye the yarn to weave the material, how could we address the dyeing part? So there's digital printing, like sublimation printing of fabric. So potentially we've looked at, could you spin a fabric in its, raw or natural color and then essentially print on it afterwards? But again, you'd have to be able to do that at scale. And that's a lot, right? So it means you're still using ink, but you're using it after you've actually created the material. Another is dope or solution dyeing. So what I can get my sheet back here so I can tell you exactly what that is. That's where the pigments are added to the polymer prior to the fibers being extruded, so that then you can make a yarn. So that's another option for dyeing. We have not seen a lot of that in what we're doing and what we're looking at. We have looked at the sublimation printing of the textile. The other is a supercritical CO2 dyeing or foam dyeing. So where this becomes important is it uses a lot less water in that process. So we've looked into that as well. Again, it's not something that's being utilized at scale domestically or abroad, but this uses a pressurized carbon dioxide as a solvent, which eliminates the water to achieve a dyeing process without water. There's also a foam dyeing, and it's essentially a solution with foaming agents that are patted on the fabric, right, to absorb the dye. And then finally, we have kind of a niche or a smaller market of natural dyes. So you've probably seen things with soy and things like that. And of course, you can imagine that the challenge there is to do that at scale. So now we're going to talk about cut and sew as we get to kind of near the end of what we look at. And this is a big part of our gap, our focus on our gap here. Is you can see here on the screen, if you can, hopefully it's not too small, the cost breakdown example of a t-shirt. So the cut and sew labor rather, if you see in the US, $3 to $4.50 per item. China, 40 to 80 cents. Other costs that go into manufacturing a garment, $4.75 to $6.80. You can see China, 220, and it doesn't have to be China. It could be India, it could be Mexico, it could be anywhere else. 380. This is a specific China example, but they're comparable across the world. And then the total cost per shirt you get here would be, $7.75 to a little over $11, and you're under $5 a shirt abroad. And then your retail price, again, 3 to 6 times what it would be overseas. So how do you tackle that? The picture you see behind is a sew shop. The only way to tackle that today would be with more automation, right? How much can be automated so that you don't need to have, 300 people in a factory? Maybe you have a tenth of that and a lot of it is automated. And so we're taking a lot of time to look at that and where people are at, what they're doing. There are pilots that are being run. I'm actually going to skip ahead and then go back. These pilots that you see here are very early stage. In the US, there is some cut and sew automation going on. The cutting technology, and we have some folks here in Denver doing this, where they're cutting out, the front of a t-shirt and the back of a t-shirt, but the sewing is still very limited on what they can do with that. Most of the pilots focus on garments, not say like comforters and things like that. Again, still early on, but as long as, the cutting is one big part that they can't automate. In Japan, they're looking at robotic sewing and hybrid automation. If you go on YouTube, you can see a lot of videos, and they're fascinating. What it really shows you is how complex it would be to automate these things that are, fine stitching that is done by hand. If you just have to sew like something, take one piece of material and, sew it in a tube, that's one thing. But when you have to go sew on, ornate objects and complex sleeves and collars and things like that, all of that's still mostly done by hand today. There's smart textile machinery. So how we've seen in other industries, we're getting CNC machines, for cutting and for putting holes and doing other things like that. Folks are focusing on this as well for textiles. So although there's a lot going on, if you have a chance to go look on the internet and look at some of the automation that's happening in China, you'll see that even though they're the furthest ahead, it's still somewhat antiquated as far as making the leap from hand sewn to totally automated. So I'm going to go back here. So what I just explained is the cutting is not so hard to automate, and the simple straight line sewing, not so hard like if you're making the tube of a t-shirt, but when you get into all of the complex garments, it gets a little bit more difficult. So this webinar, we wanted to be really also a conversation. This is just high level and letting you know what we've been looking at. Our goal here is to, like I said, we can't start with manufacturing. So what we are going to start with is looking at processing, right? How can we collect the textiles that cannot be resold? So the ones that can be resold, that's what we want to have happen with them. If they can have another life, we want that for every material in recycling and circularity. But for those textiles that cannot have another life, how can we process those? So we are working with some companies. There are many technologies out there. There's many emerging ideas of things that can happen, and how we get those to scale is really what we focus on, is how can we help move along incrementally, along this path to advance. And then the preparing of the material is another important piece. It goes a lot with the processing. We have some companies that are trying to combine and do both, so that they end up with the fiber that can then be spun and go through that process. We are looking at the dyeing and finishing, but we know that until we can get through the processing and the preparing, it's not something that we can tackle. So that's kind of on the shelf for us a little bit for the CEDC and what we're looking at with textiles. But what we are also keeping a real good eye on and talking to folks about and watching is the automation to deal with some of the manual labor. There are folks here making textiles, going back to that EPA slide, talking about who they're monitoring. There's about 135 sources of folks dyeing and making textile fabric and material here in the US. That's still not that much, right? And for the population and for what needs to be supplied. So like I said, we're going to start there. Eventually, if we can get the processing and the preparation, maybe we can look back at the MRF. We have some really great things on the horizon, I think, in this space as far as potentially bringing something to this region. But we do have all these things to work through. So with that, we're going to go to the chat. I'm going to take this down so that I can hopefully see some of your faces and see the chat and see if we have any questions. So Cam's over here in the room with me, and she's going to let me know what kind of questions we have, if we have any. Go ahead, you can just tell them to me. Yeah.
The first one was, were the numbers and statistics in the RRS gap analysis specific to Colorado, and are they consistent across the US?
Yes, they were. They were for Colorado, because Colorado is the focus for the Circular Economy Development Center. And you can read that report. It's available on the CEDC website, which is coloradocedc.org, and look at that, where they drew their data from. But it was primarily based on Colorado in this region. Next question. Can't see the chat.
Has the CDC looked into producer responsibility for textiles, given California is in their stages?
We're keeping an eye on California. Right now, what the CEDC focuses on is the infrastructure. So we really focus on that. Who can process this? How are they going to process it? What is it going to cost? Is there enough feedstock available? And is that feedstock available at a cost that is, conducive to that model, right? Will they make it? We can subsidize some things. We're really lucky to have the C3 Enterprise Fund to give some grants to get these things kind of out of the gate. But at the end of the day, these solutions in circularity also have to make some economic sense and be viable and sustainable long term.
Okay, next, going to blends.
Going to blends, can they be recycled into new blends, or do they need to be separated?
No, so blends. Oh, I think she has her mic on. So this is the conundrum, really, quite frankly, right? Is polyester can go back into polyester, so to speak, right? And same with cotton. A lot of cotton we collect here today. Numerous folks, everyone that we've worked with, one destination is Mexico, so that's not even that far as transport, and that your recycled 100% cotton can be turned back into denim. So that's simple. But when you get to the blends, that's where you're really looking at, as we see, some type of advanced recycling, right? Because you've got to be able to separate out the polyester from the cotton, from the rayon, from the different types of materials to make it into something else.
Okay. Referring to the cut and sew cost breakdown, are those prices assuming piece rate or minimum wage for the US costs?
That was done on piece rate. Yes, that example.
Given the alternatives to dyeing and finishing, have we looked into wastewear based out of India at all?
I've not heard of those, but we can absolutely look into them for sure. And if you can always reach us at info@circularcolorado.org. So if you have thoughts, ideas, information, we're a mighty team, but we're small. So, and we have multiple materials that we work with. So textiles, electronic waste, C&D, construction, demolition. If you have any information that you think that we need, please reach out and give it to us. What we normally do in our process, I'm going to take a minute to explain a little further, is we look at the gap, which I've told you here over and over, and we find one or two companies that are dealing with that. And then that's our jumping off point, right? So if a company has part of the solution, then we work with them and we go out and we find the other partners to complement that, right? To complete that circular supply chain or that circular economy. So we are not necessarily looking at everything, we partner with the universities and we have like this webinars, and we'll have stakeholder meetings, but we really, like I said, work on the infrastructure piece and find the company that has the technology or the innovation, the idea, the patents to potentially solve it. And then we kind of weave in, pun intended, the other elements of what we need to close the loop.
They're asking that you repeat the question as well.
I'll repeat the question because you can't hear Cam. Okay.
Thinking back to the dye process, has the CEDC looked into structural color?
So the question is, thinking back to the dyeing process, have we looked into structural color? No, that's not something that we've looked into yet.
Has the CEDC looked into ways to collect and recycle microfibers from the manufacturer's surplus or laundry?
Has the CEDC looked into a way to collect the microfibers from, I would assume like industrial? Is that what that's asking? Is that what the question says? And manufacturing. So manufacturing waste is something that we always look at with every material. So the fact that textiles are very aligned with plastics, and as we know, we have a lot of plastic manufacturers. So when we see a manufacturer that has a lot of PET waste or polypropylene waste or anything like that, then that is absolutely one of our focuses for feedstock. I will say, though, in Colorado, one thing we are working to change or to improve is to increase manufacturers here. We're not a manufacturing hub today, right, for the US. And so we will often look to manufacturers outside of the state or the region as well to see who's producing, what and how we could relate that back to this region or to Colorado.
How does the CEDC plan to work with collection sites like thrift stores to ensure that textiles are routed toward processing?
How does the CEDC intend to work with collection sites? So like I said, the MRF was our first thought, like, we're going to make a MRF. This is going to be, we know how to make a MRF. At the start and end of the day, that will not be the first phase of what we're doing. Because we will need, since we're focusing on mechanical recycling, we're going to need some homogeneous feedstock first. And so right now we'll continue, right, to lean on our partners in like, Goodwills and ARCs and the secondhand stores and mom and pop stores like that are doing reuse. As far as collection and the bins that you see, in parking lots and things like that, at some point when we're ready to have mass amounts of feedstock, then we would go back and talk to all of those stakeholders. Today, it's really the technology and the process to see, can we do this here and how many of those process steps can we do?
Has your team been watching the development of Design for Transportation, sponsored by the Beneficial Design Institute in Germany?
So this question is about say that one more time.
Design for Transformation.
Design for transformation. In Germany, that one's not ringing a bell to me, but we have multiple team members that are looking at all different types of things. We talk a lot to the folks back at Gaston College, back in the Carolinas, as many of you probably know. Most of what is happening in textiles happens back there. It doesn't really happen as much out here on the West. And so learning from them and saying, hey, is there a way for us to put together, a hub to incubate some of these things out here in this region, where we can secure feedstock more close to home. So we do talk a lot to the universities, and we watch everything that's out there. We watch the webinars, we talk to folks in chats and align with other states. Like, we'll talk to the folks in Washington and they're doing some great stuff with textile research and stakeholder communication. But again, we really are honed in on the technology and the infrastructure of like a single process at a time. So that's really our focus. Not quite as broad as that. Any others?
Are the challenges of blended fibers due to the variety of blends or blends by nature?
So as I said in the beginning, I am not a subject matter, deep dive expert in textiles. The question was, is the complexity the type of brand, was it the type of blend? A blend is, it's like in anything in recycling. If you don't design it to be dismantled, then you have a really hard time capturing it, right? So the second you blend PET with HDPE, you have a problem, right? You have a compound, and so now you have to, if those are not easily separated, then it's really hard to recover it. It's no different in textile, whether it's a polyester cotton, though, would be easier than a polyester cotton rayon spandex, right? Because it's more complex. Just like two parts of a plastic, item are easier to figure out how to dismantle and process than, something that has four different types of material. It has two plastics, a metal, and a cotton in it would be much more difficult. So the rules of recycling, one thing that's really interesting to watch with what we do is it's pretty standard across all the materials, right? If you have a single material, it's easier. If you add another material, it becomes more difficult. And all of that requires different technologies. And then sometimes this is why we're seeing so much chemical processing and things like that, is if we can't get them apart, then how do we separate them, right? Do we need a solvent? Do we need some other type of process to force the stuff apart so that we can then recover it and make something new?
What do you believe is the local responsibility for preventing thrift store excess clothing from ending up in landfills overseas?
Oh, what's the local responsibility to prevent textiles from ending up overseas? That is a policy question. The CEDC does not work on policy, so it's my disclaimer. And we don't really we're not going to issue opinions on that. Again, we work on the infrastructure to capture what we can to turn back into another product. If you're interested in policy, I will tell you, if you're here in Colorado, you would want to reach out to Recycle Colorado. They do a lot of that work, and it's great work. We really are operations focused nonprofit, as is the CEDC, working to do what we call tangible, actionable, measurable projects that are really based on equipment, mechanics, technology, and things like that. That's it. That's all for the questions for now. And I don't know if Christina and Kathleen, if you can wanted to say anything from CDPHE's perspective, since you guys pretty much host the CEDC. While we wait for any other questions.
Just thank you again for this webinar. We'll be sharing, the session was recorded, and so we'll be sharing that later.
Fantastic. So if there's no more questions, we can always give you back 20 minutes of your lunchtime, and we appreciate your time. Again, if you have any questions for us, info@circularcolorado.org is just the fastest way to get hold of us. And we welcome anything. Oh, we have
There was one more question.
Okay, perfect.
What our plans are for 2026 in the textile space?
Oh, our plans for 2026. What are our plans? I think they mean the CEDC and Circular Colorado for the textile space in 2026. We really are working on that processing piece. So if you remember that, and you'll see this if you download the presentation, we're really saying, well, we know we can collect it, right? So we know we can get material. How are we going to process it so it can be used, into the next phase, whether it's to go back into a textile or to go back into another product. So we're working with a couple companies that have hopefully a solution that we can scale. That's really what it comes down to. There's many solutions that work, that we see people making textiles into new products, but it's something that can scale and handle the amount of textile waste that we're seeing today in Colorado and everywhere. So really appreciate it. Appreciate everybody that made comments today in the chat. And if you're interested in getting involved with us, just reach out to us anytime. Thanks, everybody.